The question here is to find Taylor series. First four zero terms, non-zero terms, where given value of A. A is zero, therefore basically this is Maclaurin series also, right? Let's write the formula for Taylor series. Taylor series says the function can be written as sigma n from 0 to n fn of a divided by n factorial times x minus a the power n. In this case, a is 0, therefore n from 0 to infinity fn at 0 divided by n factorial times x minus 0 power n. So basically x power n. Let's find all these the derivatives. Okay, so I suggest you draw a kind of a table. In the first column you write n. Okay, so let's say n is 0, and here you write fn at x, so that is just f of x, and f0 x means just fx, that's xex. And in the third column you put value a is equal to 0. Basically you are finding fn at 0, so that will be just 0. F of 0 would be 0. Let's put 1. First derivative of the function. What is the first derivative? How are you going to find it? That's product rule, right? So x is derivative 1 times ex plus x times ex's derivative ex. Basically that can be written as x plus 1 times ex. So f prime of 0 will be what? When I put 0 in there, x is 0, 1 times e the power 0 is 1. So basically 1. Let's find second derivative. Again, first derivative is product of two functions. Therefore, the second derivative will be the derivative of x plus 1 is just 1 times ex plus x plus 1 times ex's derivatives is ex. We factor ex and we have x plus 2 in here. When I put 0 there, because we need to find nth derivative at 0, x0 e the power 0 is 1, 0 plus 2 is 2. Okay, 3. Third derivative. If you repeat the process, again this is product of two functions. Derivative of x plus 2 is 1 times ex times x plus 2 times derivative of ex is just ex. Therefore, ef factored, we have x plus 3. Third derivative at 0, when I put x0 will be e the power 0, 1, that's just 3. Similarly, I can follow the pattern now. I think fourth derivative would be e the power x times x plus 4. So therefore fourth derivative at 0 would be, when I put 0, e the power 0 is 1, 0 plus 4, 4. Okay, so let's put it all here. Our series is gonna be f of 0. F of 0 is 0. The first term is 0. Plus f of 1 of 0 divided by 1 factorial times x the power 1 plus second derivative 0 by 2 factorial x2. Third derivative add 0 by 3 factorial times x cube plus fourth derivative add 0 by 4 factorial times x4 plus so on. Okay, this is just 0. I don't even need to write that. F prime of first derivative of 0 is 1. 1 by 1 factorial times x plus second derivative at 0 is 2. 2 by 2 factorial times x square plus 3 by 3 factorial times x cube plus 4 by 4 factorial times x4 and so on. So this basically x plus, I think 2 can cancel, and this is x squared by 1 factorial actually, and this is x cubed by 2 factorial, x4 by 3 factorial and so on. So that is the expansion of our function xex using Taylor series, but a is 0, therefore it's also called Maclaurin series. So you guys notice this can be written as n from 1 to infinity x the power n by n minus 1 factorial. So for writing like this, you need to see the pattern. If the power is 2, here is 1 factorial, 1 less, right? If the power is 3, here is 2 factorial, 1 less. If power is 4, here is 3 factorial, which is 1 less. If power is 1, here it is 0 factorial because that is just 1. Therefore, our function can be written as this power series.